Hi, everybody. Hello, welcome. So let me just point out where we are in the sequence of the course. Remember, the subtitle is Cosmos, Earth, Life, and Humanity. We did the cosmos part early on. Then we had a couple of kind of intermediate topics that sort of tied them together. Now we're starting into geology. And you will have noticed that I'm unafraid of talking about other people's fields, hoping that I get most of it right. Now we're into my field, so I'm in my comfort zone right now in geology. And if you check out the schedule, we'll see that maybe there's a little more on geology than there is on some of the others, because after all, you are taking a class in a geology department. So that's where we are, and I want to spend the next few times trying to get you infected with enthusiasm for geology, what all of us in this department have. So let me ask you, how many of you have had a geology course? A few. Where did you have it? Middle school? Junior high? Here. Oh, here. Okay, good. In high school? What? Community college. Community college. Okay. But let me point out something that has always struck me, and that is that in high school, everybody who's going to college is going to have to take some mathematics, and you're going to have to take physics and probably chemistry and probably biology, maybe some astronomy. And occasionally somebody takes a geology course, but not very often. And that's going to be my topic for today. Why is geology left out? If you detect a slight bit of defensiveness, you're right on target. And I'm going to talk about that today. Let's think about it. Almost seems like there's a pecking order of sciences, with mathematics at the top, and then physics, and then, I don't know, chemistry, biology, something like that. Geology's kind of down near the bottom, in all honesty. And I think that's completely wrong, and what's more, it's stupid. So think about this. Biology gets huge support. There's a whole national, what is the health, National Science Foundation, but also there are all sorts of funding opportunities in the biosciences, and that's great. You know, when we get sick, we want the doctors to know how to cure it, right? And so I think that's why there's so much support for the biomedical sciences. There's not very much support for doing research in geology, for understanding this planet. And let me tell you what the problem with that is, you know. If I get sick, or if one of you does, something happens to us, which it eventually will, there's lots more people to take our place. We live on the Earth. There's only one Earth. And if we screw it up, we're all in real bad trouble. So it seems to me that the number one science for the 21st century ought to be geology. How's that for self-interest, huh? But that's not the case. And so what I want to do with you today is explore a little bit about why that might be. Why is it that geology, what is the name of that guy who didn't get no respect? Why is it like that? And I'm going to offer a possibility or two, and then I'm going to try to cure one of those problems. And it's going to tie history to geology to Spain. So it's got everything I love in here. All right. Okay, so why does geology not get more respect? Well, for one thing, it's hard to be as clean mathematically about the Earth as it is about, say, planets in orbit. And so astronomy and orbital physics can be done with very neat, clean equations. That's because there's no friction out there, and what's more, there's not very much history. You know, the planets are going around today just like they went around 1,000 years ago or 1,000,000 years ago. It's tough on the Earth because you're dealing with a very, very large, complicated system with history behind it. And so it has always just been harder to do geology than physics. I would say that physics requires some very sophisticated mathematics, but once you've got that, you can do it neat and clean. So my father was a physicist, as some of you know, and he used to say that he would stick to physics, thank you, because geology was just too complicated for him. So that's part of the problem, okay? For example, I have a picture of him someplace or other that we took in Italy. We went to an outcrop where the beds are dipping like that. And he said, I thought they get younger piled up like that. And I said, yeah, but they get tilted. And he thought about it for a while, and he said, you know, that's going to be too complicated to explain when I give lectures to audiences of physics. And so what he did was to sort of lean over on the outcrop so that he was perpendicular to the beds, and he had me tilt the camera and take a picture so it looks like it's upright. And that would be something you could use for physicists, right? Okay, so maybe that's part of the problem. Another part of the problem is that the hierarchy of sciences seems to have emerged around 1900, something like that. And that's when the curriculum that we still use for the universities was set up. Eldridge Moore's up at Davis. Remember, he was in the first lecture about Cyprus. He's been fighting this in California for years, trying to get geology to be one of the courses for which you can get advanced placement credit to get into the University of California, which you cannot now. At any rate, at that time, around 1900, when that was set up, physicists were exploring the deepest secrets of the universe with quantum mechanics and with Einstein doing general and special relativity. And they were really pushing through to as deep into understanding how things are as anybody has ever done. What were geologists doing at the time? We were out banging on rocks all over the world and bringing back specimens saying that one's a sandstone, that one's a limestone. It was not terribly sophisticated scientifically, but it was necessary because this planet is so complicated. If you wanted to understand it, you have to know what is everywhere. See that map over there? Let's check out that map for a moment. See all those colors? Maybe you can recognize parts of the world that you know there. Maybe you can see them. Maybe you can see that that's Africa and that's South America. They're almost buried in all of the colors there. And those colors are there because thousands of geologists over the last century or two have gone out and they've found out what was in all of those places. So you had to do this. But when the hierarchy of sciences was set up, geologists were doing this rather routine thing, and Einstein was penetrating almost into what he called the thoughts of God. So maybe that's why geology doesn't have as high a reputation. It should now, because the things we're finding out about the Earth are equally as subtle and sophisticated and profound as any other science is. But let me give you a third reason, possible reason for this, the lack of prestige in geology, and that's what I want to talk about today. When you talk about the history of science, say from Renaissance on or something like that, the last 300 or 400 years, people will point out that astronomy was studied by Copernicus back in 1540 something, right? And Newton, and these guys were doing this work hundreds of years ago, like 400 years ago, 300 years ago, something like that. And the history of geology is said to go only back to about 1800. That's what most geologists think. It started with a guy named Hutton. At least if you're in an English-speaking country, it started with Hutton, who was about 1800. And it was as if nobody cared about geology before that. So geology is considered a young science, almost a scientific Johnny-come-lately, compared to these venerable, old, profound sciences like astronomy and physics that go way, way, way back, all right? That may have something to do with it, and that's what I'm going to argue against today. Because what I want to do is to show you a new interpretation which says that geology is at least as old as astronomy and physics, at least as old as science, that people were making important advances in it at least as far back as physics and astronomy, and in fact, probably 100 years before Copernicus, great geological discoveries were being made. And I'm going to finish off by suggesting to you that the scientific revolution, the start of modern science, was not a development in astronomy and physics, it was a development in geology. And the problem is that geologists don't think about these things. They learn what they learned in school, started with Hutton in 1800, and they never think about these older things that we ought to consider to be part of the history of geology. So that's what I'm going to be talking about, and I may get kind of excited about this at some point today, okay? So, here we are. This man is Henrique Leitão at the University of Lisbon in Portugal, and he has become a dear friend. He came here to Berkeley about 4 or 5 years ago and gave a lecture, and I met him, and we just discovered we had many interests in common, and we've actually just published one paper, and we have another one that's just coming out right now. And he is a historian of science, but before that, he was a physicist. So here's a guy who's both a historian and a scientist. And we have found it just delightful to work together. And I've put our new paper, the one that's relevant today, on BSpace, so you can find that and read it. It's Leitão and Alvarez. Okay? So, here's the point I was making. Geology is arguably the most critical science for the 21st century because we only have one planet, but it lacks the prestige of most other scientists. Why is that? And maybe it's because geology is considered a young science. So I'm going to try to show you now some things that happened very long, very far back, which I think are geology. And see what you think about it. So I love this picture. This is a satellite image, and in this one it's daytime in the west half and nighttime in the east half. And it's almost for me, it's a symbol or a metaphor. And I want to take you to this place that you've heard about before, to Iberia. And this time it's going to be more focused on Portugal than on Spain. And let me tell you this story. Okay, so here's the area we're talking about. Portugal off in the west. Remember, we talked about how this is a geographical fossil because before there were other Christian countries that were moving this way toward the south, gradually reconquering the Moorish territory. But all of the others got absorbed in Castile, which originally came from Burgos, and only Portugal was able to keep its independence. So it's a leftover from the Middle Ages, right? Okay. So, how many of you have traveled around in Spain? Some of you? Few? Okay, some have lived there. Okay, great. If you go there, what you will see is lots of wonderful Gothic cathedrals. Like this one, there's Burgos up there. Here's the Cathedral of Burgos. Just absolutely magnificent. When you go in these churches, anywhere in Spain, what you will find is decorations that are about kings and queens. They're about the high church hierarchy, like bishops and cardinals and popes and things like that. And they'll look like this over here. So there's royalty and nobility and Christian symbolism all through these things. That's what the decoration is in these Gothic churches in Spain. Okay, now let me take you west across the border and show you a Gothic church that's different. And by the way, I like to think of this as geologists are used to reading the history of the earth written in rocks, but here we're reading the history of the science of geology written in these carved stones. Okay, so let's go now to Portugal. This is the monastery of the Jerónimos in Lisbon from early 16th century, so this is about 1500 or a little bit afterwards. And this is Gothic. You can see from the pointed arches here, you can see from the sort of general spirally kind of thing. This is a Gothic building, and it's in a different style, which is exclusive to Portugal. It's called Manueline, which is down here. So Manueline means that it was built in the time of King Manuel I, which was around 1500. And at first you think, well, just another Gothic church building. But you start looking at the decoration on this, and it doesn't look like the decoration in those Gothic churches in Spain. What does it look like? See that thing there in the circle? That's a rope. So there's rope everywhere on this cathedral, carved in stone. And then if you look at some of the decorations, you'll see things like that. Well, up here, for example, this is rope woven into the kind of thing that a sailor would make. And here's some kind of an exotic flower from some tropical realm. And here's a ship's cap stretched out on a square knot. Now, what is this doing in a Gothic church, I ask you? It's different. And then you look at it some more and you see, for example, over here, here's some kind of a seashell in it. And seabird. And this thing, what do you suppose that is? Yeah. A compass. It's close to a compass. It's related to a compass. This is a thing that's called an armillary sphere. And basically, these things represent latitudes. And this represents longitudes, and this is the tilt of the Earth's orbit across here, and you can hang it from your finger. This was a device that was invented in the late Middle Ages to help sailors understand how to navigate at sea. It represents the Earth and the orbits of planets around it, and it was so important in Portugal in the Middle Ages that today's Portuguese national flag has an armillary sphere on it right here with a heraldic shield on top. But this stuff doesn't look like the cathedrals of Spain. It's very Portuguese. And you look at these things here or at any of the other manual-line buildings in Portugal. There aren't very many because there was a terrible earthquake there that knocked most of them down. But the ones that you look at, you just smile, you laugh. There's so much fun. Somebody was having fun with these buildings. And what you sense from it is that there was excitement, there was delight in novel things that was in Portugal at that time. Very different from what you see in Spain. Now, why was that? Okay. In order to understand that, we have to think about the history of geology. So let me give you my take on the history of geology. This is not what you will find in any history of geology book that you pick up in our library. This is a sort of set of ideas that Enrique and I have been developing. We've been having great fun doing it. And obviously he's important because he knows about Portugal, being Portuguese. And I know about the geology part, so we're having great fun together. Okay. So how would you organize a history of science if you were doing it, of a science, specifically geology? Well, I think there's two ways that you could do it. The usual way that you'll see, most of those books in the Earth Science Library, are organized around, they are chronological catalogs of particular scientists like James Hutton. And it will tell when that person lived, what that person did, what they worked on, why they were important, then they go on and do the next one, right? And some of these books are almost like reading a telephone directory, you know? All these people, only they're ordered by chronology rather than by their last name. And you can see what they all did. That's okay, but the trouble with it is, the longer a book you're planning to write, the more people you can put in it, and it just eventually becomes just a list. And it doesn't give you much of a feeling for the important things that were happening. So the second way that you can organize it is as a set of scientific revolutions in the sense of the philosopher Thomas Kuhn, in each of which a previous ruling theory or paradigm was modified or overturned. How many of you are familiar with Thomas Kuhn? Okay, so Kuhn was a philosopher of science middle of the 20th century, and he challenged the usual view, which is that science just kind of progresses in order like that and gets more and more, you learn more and more all the time. It's kind of a continuous climbing path, as it were. And Kuhn said that isn't the way it really works. The way it works is that a ruling theory gets established because it's very, very successful, and he used the word paradigm, which you've probably heard in other connections. He used the term paradigm for this ruling theory. So, for example, when Newton figured out how gravity works and how it keeps the moon and the in orbit around the Earth and the planets in orbit around the sun, it worked beautifully. It was absolutely fabulous. We still use it. That's if you have to plan if you're at NASA and you're planning to get a satellite from here to a moon of Jupiter, you use Newton's equations. They work perfectly. And so that was a paradigm, a ruling theory, and it lasted for probably 300 years. And then it gradually became clear that it wasn't working in some cases. For things that went really fast, it didn't work. And so Einstein's theory of relativity is a modification of that Newtonian paradigm that explains how things work when they're moving really fast. And so what Kuhn said was that you have a paradigm and it works for a long time. Then you start to find places where it doesn't work. And then there's a paradigm change or a paradigm expansion that takes you to a new paradigm that explains more stuff. Okay? So what Enrique and I thought we would do is to think of geology, the history of geology, in that way as a development of paradigms. So we're not so much interested in particular individuals as we are in major shifts, major improvements in understanding the Earth. Okay? So now let me take you to a timeline. What do you do first with a timeline? You see which way it runs, right? So can you see which way this one runs? Old is at the bottom, 8th century, 20th century at the top. So this is old to young there. And each one of these is a century in there. And I wanted to show you the paradigms or the paradigm changes, let's say the revolutions that have happened in astronomy and physics, because they're the ones that are best known. So you start out here, this was all pre-Copernican astronomy. This was all based on Ptolemy, who's way down about on the floor level there because he was in, I think, the 2nd century AD in Alexandria in Egypt. But that went on a long time, all through the Middle Ages, and then it was Copernicus who made the critical breakthrough of saying the Earth is not at the center with everything revolving around it. The sun is at the center. So that was the heart of the Copernican revolution. And that goes on and up through various people up to Newton, and Newton was the one who showed that the reason for it is because gravity works like an inverse square law, so that if you're twice as far away, gravity is 4 times weaker, and he showed how it worked, and you can use those to plot a trajectory that will take a spacecraft from here to the moons of Jupiter. Okay? So this was a great revolution in astronomy and physics. It's often called the scientific revolution because that seems to be where modern science started. At least that's what people say. And then there were some other things like Maxwell's equations that clarified how electricity and magnetism work. And then in the early 20th century, there was quantum mechanics and Einstein's relativity. Each of these bringing a whole new understanding of a whole new range of phenomena in physics. And then remember there was Hubble and Humason who discovered the expanding universe, and then that led to appreciating the Big Bang. So, you know, different historians would come out differently with it, but this is a reasonable, what would you say, analysis of what has happened in astronomy and physics. Yes, yeah, Natalie? The Big Bang Theory came out about the middle of the 20th century. And there was a long fight over it. And eventually it was the discovery of what's called the cosmic background radiation that made it quite clear that that was what was happening. And remember, there was a man named Fred, maybe I told you this, there was an English astronomer named Fred Hoyle who did not think that the Big Bang was right. In fact, he was the one who used the word Big Bang because he was making fun of this theory. And it turned out he was wrong, and the name that his prejudicial name stuck. So anyhow, that's what happens. Scientific revolutions are amazing times. I've lived through one and maybe a second one, and I'll tell you about them because they're just amazing. So anyhow, that's what happens in astronomy and physics, kind of the canonical top prestige sciences. Let's look at geology. And geology, study of the Earth, and more broadly taken, if you include things like atmospheric science and planetary science, it's called, as in our department is now called, Earth and Planetary Science. Well, here are the two obvious major revolutions in my science. The first one is this one around 1800 that's associated with James Hutton in Scotland. And that was the one where people figured out that you could read Earth history written in rocks. And that Earth history went way, 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 way back. That biblical time scale that said that the Earth was formed a few thousand years ago, that was far too short. That the Earth history was thousands of times longer than that. Okay, so that's a geological revolution. Ryan?
What about Charles Lyell? The biologists are always taught about Charles Lyell and not about Hutton.
I have a problem with Lyell because Lyell believed that everything was gradual. And so a lot of the grief that I've taken over the years over the impact theory is because most geologists were Lyellians. And so I'd be very happy to talk about Lyell, but I thought I'd leave him out here so that I wouldn't waste your time on him. But that's absolutely right. It's a very good point. And the other great revolution happened. It started when I was a graduate student. And in fact, my professor was the guy who started it, and I didn't have anything to do with it except I had a really good ringside seat. But it was the plate tectonic revolution. And prior to that, most geologists were convinced that continents, like over there, South America, Africa, Australia, that they had always been exactly where they are now, that there weren't any motions that took place. And plate tectonics, or continental drift, which is another version of it, is the one that says, look, this fits into there, and these have spread apart, so continents actually move around on the surface of the Earth. That was a full-bore revolution, and you're about to hear more about that. Okay, I think you might put in a couple of more. For example, here's Darwin's revolution, and that is the one in which evolution, the fundamental theory of biology, was developed. And in fact, it was developed on the basis of fossils that geologists and paleontologists had found while they were reading the history of the Earth. And so Darwin actually thought of himself as a geologist. And when he went on the voyage on the Beagle, he made lots of observations on geological things. So evolution is fundamental both to geology and to biology, and it ought to be on our list of revolutions. And now there's another one going on that it doesn't really have a name. I called it here neo-catastrophism, because you see, Ryan's friend Lyell was absolutely against any kind of violent or catastrophic change. He didn't think anything violent or catastrophic had ever happened in the history of the Earth. And he was very influential. He was a very persuasive writer. He was around 1830. And he wrote a book that was so influential that geologists came to think that nothing exciting had ever happened in the history of the planet. It was all very slow and gradual. And so things like the impact that caused the Cretaceous-Tertiary boundary, the impact that generated the moon, really large volcanic eruptions, mass extinctions, those are things that Lyell would not have tolerated. And yet we now know that they did happen. And so there has been a revolution that it doesn't say that everything's violent and catastrophic, just that there have been catastrophic events, and Lyell was too extreme. So that's what you would maybe say was the history of geology in terms of revolutions. Now what I want to do is to turn back to this scientific revolution that started with Copernicus and climaxed with Newton, and make the point that Henrique and I made in a paper that was published last fall. And what we're saying is, sure, that was a revolution in astronomy and physics, no question it was. But it was also a revolution in geology, and nobody thinks about that. And let me show you why. Let me show you the arguments for it. First of all, let's think about the words planet and Earth. Okay. Now you probably have a clear view of this. You know that planets are objects that go around the sun and that the Earth is one of them, right? Let's imagine that you were a medieval scholar. Let's say you were in 1300 or something like that, 1200. You're at one of the great universities of the time like Bologna or Oxford or Salerno or someplace like that. And what would you think of planets and Earth meant? You'd have a very different idea than we do now. Here's what you would think. That Earth, to you, would be the surface that we live on. It's rocks, soils, and water. And it's also one of the four elements. What are those? Earth, earth, air, fire, and water. That's what everything was thought to be made of. That was the Greek view that came down from Aristotle. So you would think Earth was the place you lived, and it was one of the four elements. What would you think planets were? Okay, now a planet, that comes from asteres planetai in Greek. That's the total extent of my Greek, and it means wandering. It means wanderers. And what you'd see if you looked in the night sky and you didn't look in a place all full of lights like Berkeley or Los Angeles, what you'd see is that there's stars out there, right? And they're constellations. And then they stay in the same place relative to each other always. These stars do not move relative to one another. The whole business goes around the Earth every day, but the relative positions stay the same. But there are other lights in the sky that go across like this, and they wander around. Then for a while they turn backwards, and then they go this way again. And they were a different kind of star. So asteres planetai meant wandering stars as opposed to fixed stars. Okay. Remember, you're back at Salamanca or Salerno or something in 1200, you're a scholar, and you think, somebody asks you, what's the relationship between Earth and planets? There isn't any. Earth is what you walk around on, and planet is it's at the center of everything, right? And planets are lights that move around in the sky. They have nothing to do with each other. They have about as much to do with each other as, let's say, plate tectonics and B flat minor. It is simply nothing to do with each other at all. But after the Copernican revolution, it was understood what we understand today, which is that Earth is a planet. Now, can you imagine what a huge change that is in understanding? It would be as if somebody were to discover right now and publish, and we would all accept it, that plate tectonics was composed in the key of B flat minor. I mean, right now that sounds absurd, and that's just about how different this was. But that, my friends, is a difference in understanding the Earth. If you don't know that Earth is a planet orbiting the sun, you don't know anything about the Earth. You have got nowhere to go in building a science of geology. So the point that Enrique and I are making is that the Copernican revolution was every bit as much a revolution in geology as it was in Earth and in physics and astronomy. So conclusion, in the old time, in medieval time, planets and Earth are utterly unrelated concepts. Here's Copernicus, and this is the drawing here now that's completely different from the way before, because previous drawings would have shown the Earth at the center and everything going around the Earth. Now he's got the sun at the center, and here's Mercury, Venus, there is the Earth and the moon going around it. There's Jupiter and Saturn and so forth. So the point is that Earth is a planet, and this just changed everything. But let me point out that in fact, Copernicus was a better geologist than he was an astronomer, because the astronomical version is that the sun is the center and everything revolves around the sun. That's the astronomical version of the Copernican revolution. And that's wrong. Completely wrong. Because you've seen pictures, you know that the sun is not at the center of everything. The sun is a minor star out at the edge of one galaxy, and there are 100 billion galaxies. So the sun is not at the center of everything. So in a sense, Copernicus was wrong about astronomy, but he was right about geology, because nobody since then has ever said that Earth is not a planet. So, take that. That tells you that the Copernican revolution is part of the history of geology. Okay, so now let's go on. I want to show you the other part, which is going to take us 100 years back further, because Copernicus died in 1543, I believe, and that, is that what it said? Yeah, 1543, I think it said. And that was the year in which his book was published. He kind of waited till the very end so that he wouldn't get in too bad of trouble for this. But at any rate, I want to go back 100 years earlier and show you that the history of geology goes back to 1450 or thereabouts, before any revolutionary changes had happened in astronomy and physics. So let's look at that. So here we're going to go back to what we talked about yesterday, about this time from 711. Remember, that's the convenience store date when the Muslims conquered Iberia. And so Islam was dominant in Iberia for more than 300 years after that, and built great mosques like this great mosque in Cordoba, and did wonderful science. There were great scientists in Islamic Spain at a time when the rest of Europe was really in darkness, in intellectual darkness. And so now let's see what happened, because that didn't last. So we get up here to about 1050 or something like that, and the great central city of Cordoba has now fallen. And we're in the time when the Christian kingdoms, as we talked about on Tuesday, were beginning to reconquer the peninsula. So on this map that's down here, I hope you can see it, on this map, which is from 1100, this area, the three greens areas here, that is Islamic Spain, or Islamic Iberia, and here's Christian Iberia starting to work its way back. And so this is the period in here from somewhere around 1030 or something like that, up to that watershed date of 1492. This is the Spanish reconquest, sometimes moving forward more rapidly, sometimes stalled for a long period of time. But that's the time when the Spanish reconquest took place. Let me kind of give you a hint as to why this is important. During that time, the Spanish were completely preoccupied with the fact that there were still Muslims in the area that they thought should be Spain. So that's what they were interested in. They were interested in reconquest in this period. Okay, now over here, you see the situation a little bit later. Here's 1145. Here, this part is still Islamic. Now you see here these various kingdoms that are moving southward. So here's Leon, Castile, Aragon, and this is Portugal over here. And Portugal, remember, is the only one that lasted. Now there's a really important factor here, and that is that down here in the south of Spain, there are high mountains. And the kingdom of Granada, which was the last of the Muslim kingdoms, was right in those mountains. And it was just impregnable. It was really hard for the Christians to conquer. In fact, it lasted 250 years after all the rest of the Islamic kingdoms were gone. So all that time, up until 1492, which was the date when this fell, that's what Castile and the rest of Spain was occupied by. Portugal, meanwhile, had gotten all the way down to the bottom. I guess I mentioned the Battle of Las Navas de Tolosa in 1212. This was that really important battle that turned the tide. But now, let's see. There it is here. I'm getting a little distracted on this here, but look, this red portion here, that's the Spanish reconquest. This is the Portuguese reconquest. And they finished sooner. They finished like 250 years before the Spanish did, because there weren't any more Muslims to fight on the western side of Iberia. Okay? So here's the situation now. In 1250, what you see is Portugal has completed its conquest. There aren't any more Muslims down here. Nuts. That's a shame, right? Nobody to go and beat up on. But the Spaniards over here, the Castilians, the Aragonese, are still facing this remnant of Muslim Spain, which was the Kingdom of Granada. So here's the point of all of this. there is a period then from about 1250 on when the Portuguese don't have anybody left to fight. They fought the Castilians for a while, but then they eventually found themselves in the position where they didn't have anything to do, and they had all of this energy. What were they going to do? Well, they started exploring, and that's where we're coming to. So this is when the Portuguese voyages of discovery happen. They really are in the 1400s, in the 15th century, so right in there. And I'm going to make the case that those Portuguese voyages of discovery are a key point in the history of geology, and in fact that they mark the first scientific revolution in geology 100 years before the Copernican revolution that started astronomy and physics going. So that's the point that Enrique and I are making in these papers. The history of geology goes far further back than geologists ever think about. Okay, so now let's see. So here are the Portuguese voyages of discovery. Now remember, the Spaniards get rid of the kingdom of, they conquer the kingdom of Granada in 1492. And that same year, Columbus comes back and he says, hey, look guys, there's a whole continent out there across the waves. He thought it was Asia, but everybody else quickly figured out it was the Americas. And so suddenly the Spanish have no more Muslims to fight and a whole pair of new continents to explore. They just exploded into that area following Columbus. So this is the Spanish voyages of discovery. The Portuguese started about 100 years earlier. So I want to show you something about that now because it's a fascinating story. So, who's heard of Prince Henry the Navigator? Okay, he was a prince, not the crown prince of Portugal. His brother became king. But he was interested in exploring. We don't know why. We don't know whether he was trying to find gold or trying to find other Christians to fight Muslims or whether he was just curious. Nobody knows. Trying to find a way to India. But what we do know is that he started fitting out little ships of explorers to break out of this kind of confine that Europe was in. Put yourself back in the time. Okay, look on that map over there. There's Spain right there. There's Africa. If you were a European, you knew about this much maybe in there. You knew a little bit about North Africa. You knew out as far as England, Scandinavia. You probably, some people knew about India and China, but that was it. That was the world that was known. Take and paint white paint on the rest of everything there and put a sign that says, "Here be dragons." And that's the way it was. And it was Henry and his sailors who first started to break out of that tiny little box that people were in. So let's see what he did. So he set up what you might think of today as a scientific research institute. I mean, it wasn't quite that because this is a modern concept, but this is the forerunner. On the Cape, I meant to show you it in a previous picture, but this is the sort of southwestern Cape of Portugal. Really inhospitable place, and the thing is all gone now, but probably right in here someplace. He had I guess there's a port just out of sight there. This is where he set up his center for exploring down the coast of Africa. And he brought together all of the people he could find who would be helpful in this exploration procedure. So this is this painting from the Maritime Museum in Lisbon is the allegory of Prince Henry's school of Sagres. Sagres was the name of the place. That was also called Cape St. Vincent that I just showed you. And he was probably never this formal or organized, but the idea is here is Prince Henry, and with him are a bunch of guys. So here is a fellow with a model of a ship. He was a shipbuilder. Here's a guy with an astrolabe that we'll talk about, which is a navigational device, so he was a navigator. Here's a guy with a sword. He was the military people. There's another astrolabe. Here's guys making maps. Over here is a priest with things. Here's another guy with a navigational instrument. The point was he brought together everybody he could find who would be helpful in doing this exploration. Exactly what scientists do today. And he was maybe the first in European history to do this. Okay. So the Portuguese and Spanish voyages of discovery are well known. Historians have written all about them, but they're always considered to be the history of geography. And geography is basically what is where on the surface of the earth. Geologists don't take this as part of their history, but we, Enrique and I hope our papers will convince people that they ought to do that. So let me show you something about whether they should be considered part of geology. Well, if you say that astronomy and physics, if you say astronomy was science, then you'd say the early astronomers were interested in where the stars are located and how the planets move. It's very analogous. The Portuguese sailors, the discoverers, they were interested in where the coastlines are located and how the winds move. So it's very much what is where and how does it move. Both astronomers and the Portuguese explorers were doing this. And the Portuguese discovered things on the earth which today are absolutely fundamental and central to geology and earth science. Isn't there somebody here who's interested in atmospheric science? Wasn't there somebody? Yeah, okay. All right, so keep your eye on this, because these guys were the first people who discovered how the winds move, which is what atmospheric science is all about. And also they discovered the coastlines. Look over there. See that match between North America down to South America, how that loop there is where Africa fits in? This was discovered and mapped by the Portuguese, and so was Brazil, and this part was mapped and discovered and mapped by the Spanish. So the point is that it was that fundamental data set of what the coastlines, or how their layout is, that's what made possible the understanding of continental drift and plate tectonics. Hundreds of years passed, but these are the guys who found the fundamental data. So our point is, yes, you really ought to consider this part of the history of geology. Now let me tell you a little bit about, I'll skip over that because this is just the match of the coastlines. There's what these guys discovered in 1500s, and here is the match of the two. This is with Africa put up against the Americas, and basically that line there, which is the match, was discovered by the Portuguese and the Spanish. Okay, so we should, yeah, right.
Where was what is now Mexico?
That's how did you notice that? That's very quick to have noticed that. Yeah, early on this was a problem because there didn't seem to be any place to put Mexico. Good for noticing that. What we now understand is that Mexico is an assembly of smaller pieces that used to be up in here and have sort of been stretched out together, and that you take the pieces that were there and kind of stick them up over here in small pieces, and then as the opening takes place, this moves away from North America and those pieces kind of end up stuck in there, so they're assembled. Really good point. Okay, so what I want to do now is to show you the similarities between the modern scientific revolution that I know best because I lived through it, and that was the plate tectonic revolution, and what was going on in Portugal in the 15th and 16th centuries. All right, so I'm going to show you various comparisons here. This is a topic, what paradigm used to be, and then over here is going to be what the case was in the plate tectonic revolution in the 60s and 70s of the 20th century, and the Portuguese voyages of discovery. Okay, all right, so let's think about what was the preceding paradigm. What did people think before the revolution? Well, in the case of the plate tectonic revolution, they thought that continents were fixed and that oceans were permanent. So if you looked at that, see that's the Central Atlantic Ocean there, the South Atlantic Ocean there. Before the 1960s, people thought that those had always been there. What we now know is that Africa used to be up against the Americas, and all of this ocean has grown since then at a rate of like the rate your fingernails grow. Okay. So there was a similar case in the Portuguese voyages of discovery. Before the Portuguese voyages, they thought that the Indian Ocean was completely closed. Look at it now. See, there it is. It's open right through there, and it's open south of Australia. So they thought that the Europeans before this revolution, thought that the Indian Ocean was closed, and what's more, they thought that there was more land on Earth than there was water. Now we know there's 2/3 of the planet is made of water, right, or is covered with water. Okay, so here is a map from the Middle Ages. You can see it's very schematic, and what you're reading is there's Asia, there's Europe, there's Africa, and the cool thing about that was you could make a T and a circle because normally that side is up. So the medieval maps, early medieval maps, were really more illustrations of a concept than they were compilations of data. But then when you went on, you started to get these, like this was an Arabic map from 1150 something, and the Arabs were wonderful geographers and explorers, and they made maps like this. But here, what you'll see is here's Europe. See Spain, Italy, Greece there. This is North Africa. There's Jerusalem's over there somewhere. This would be now Saudi Arabia. There's the Indian Ocean. And you see I emphasized with the red line that they said you couldn't get out that way. Maybe you could get out. This was this sort of, they all thought there was some tiny little narrow sea that encircled the continents. But the point is, the important point is they thought you could not get from here to the Indian Ocean. Maybe by sailing all around past the South Pole you could, but basically it was landlocked. And then as you go on, here is a map that was drawn in the Middle Ages, but it was, in the 15th century, and it was based on Ptolemy the Greek from the 2nd century AD. And what you see then, again, here's Spain, there's Saudi Arabia, there's India, Ceylon or Sri Lanka is drawn very big. But again, see, it's an enclosed thing, you can't get there. So this is what they thought at the time. And what the Portuguese found out was that that isn't true. You can sail around Africa and get there. This is a fundamental change in understanding the Earth. Not only that, but that there was a lot more water around than there was land. So it's just like plate tectonics, big change. Okay, now, often in a scientific revolution, what makes it happen is that there are technological advances. So in the case of the plate tectonic revolution, bathymetry means measuring the depth of the ocean. They do it with sound waves reflecting back up, and you take the time. Magnetics, seismology, studying earthquakes. Paleomagnetism is finding out which way the compass used to point in some place. And all of those were technical advances that made the scientific revolution of plate tectonics happen. Perfect analogy in the case of the Portuguese voyages of discovery. Remember, what I'm trying to do here is to make the point that this was a scientific revolution, and it was a geological scientific revolution 100 years before Copernicus. What were the technical advances? Well, they had kinds of ships here, caravels and naus, I will show you in a moment, the nautical astrolabe, and they learned how to do navigation, which is what you needed if you were going to sail all around this huge globe encircling world ocean. Let me just point out, prior to that, people sailed the Mediterranean. Can you see over there? It's a little hard to see. There's Spain, the Mediterranean is that. Now, if you were sailing around in that, navigational problems were not near as bad as if you were sailing around in this, right? And so the Portuguese had to learn how to navigate in the open ocean, which had not been necessary in the Mediterranean before. So let me show you these technical advances. First of all, the ships. This is a caravel. This was an explorer's ship. This is what they needed for exploring and find out what was where. First of all, it was small. It was modified from Portuguese fishing boats, and it had these triangular sails. Anybody here a sailor? Okay. Well, what the triangular sails let you do is sail close to the wind. If the wind is blowing that way, it's easy to sail that direction. You can also sail at right angles to it, and a good sailing ship can actually sail into the wind. They can't go like that, but they can go at some angle. That's called tacking, or sailing into the wind. And it was easier to do with these triangular sails that the caravels had. So this little ship would let a few guys go out and explore places that nobody had ever been before, right? And it was small enough that if it got a hole in the side, you could kind of push it up on the beach and fix it. So this is what they used for exploring. And once they found out which way the winds blow, and this was mapping the winds was done with these little ships. Once they found out which way the wind blew, then they could plan their voyages so that they would always have the wind behind them. And then they could sail in one of these things. This is called a now. And these things, this is probably even a little too large for scale. This is much bigger than that was. And it's square rigged, so the sails are like this. You can tack this into the wind, but it's much harder. It's a lot of effort to do. But imagine if the wind is blowing that way into this sail, this thing can go like crazy. But you need to know which way the wind is blowing before you go out and start your journey. So they used the caravels to map the winds. Once they had the winds mapped, then they could sail the nows in front of the wind. And in the process, they learned all these interesting things about how the Earth works. So then they had to know where they were. So this is an astrolabe. This thing is usually about this big around. This was the personal computer of the Middle Ages. This was the most important scientific instrument that people could carry around with them. And what happened was, it's got a little ring on the top there, and you hung this, you suspended it from your finger so it hung down. And then on the back side, it has you can't see it here, it has a thing that lets you sight what's the angle from the horizon up to a star or the sun or the moon or something like that. And then this thing on here, this beautiful looking thing, is a star map, or a map of the sky. And then this thing it sort of turns around it, and it has little pointers that point to particular stars, really bright stars. So you could find the height to that star, and then you could turn this around until the little pointer was in the right altitude, the right angle, vertical angle, and you could find out what your latitude was. Very hard to find longitude. But now picture the problem. Supposing you are Gillianus, we're going to meet him pretty soon. He was one of the explorers in these little ships. And he was trying to find out what his latitude was. He's out there on the ship. Okay, you're on that ship. You're out in the middle of the Atlantic. What's it doing? It's going like this, and probably you've been out on this ship now for months, so you're no longer losing your lunch over the side every time it goes. You're used to it. But you're trying to use this little thing about this big around. It's a thin plate of brass, and the wind is howling, and the ship is rolling. It's just going to be flying all around. There's no way you can take an accurate sight. So the Portuguese invented something that's very simple but very effective that's called the nautical astrolabe. And the nautical astrolabe was designed to get around that problem of using it on a small ship rolling in the waves with the wind blowing fast. And so here's the sighting arm, and what they did was made it out of heavy metal. You hang it from your finger, and there was a great big chunk of metal down there so it would hang vertically, and then they pierced it with these holes so the wind would blow through it. And this simple little change let them measure those vertical angles and find out where they were. Nobody ever needed to do that in the Mediterranean, because the Mediterranean isn't very far from north or south. You get lost in the Mediterranean, all you do is you just sail up to the nearest shore and say, where am I? Like Odysseus would have done. In the Atlantic, you can't do that. And so these instruments and ships made this all possible. Now, it takes money to run a scientific revolution. In the case of the plate tectonic revolution, it was the time of the Cold War. So there was money from the Office of Naval Research, Office of the National Science Foundation, because this country was trying to be scientifically more advanced than the Russians, right? And so that's where the money came from for all of those things that made plate tectonics happen. In the case of the Portuguese voyages, Prince Henry had been made the commander of an order of Portuguese Christian knights. Remember I showed you the castle of Calatrava last time, where the Knights of Calatrava were? Well, there was another order called the Order of Christ. And now the reconquest in Portugal is over. They make Henry the Grand Master of this wealthy order of knights, and he just cleaned out the treasury and used it to finance these exploration editions. So this is the cross of the Order of Christ, and maybe you've seen paintings, imaginative paintings of Columbus's ship or other. They always have this cross on them. That's the cross of this particular order, and that's where Henry got the money to pay for the voyages. So it's just like plate tectonics in that regard. What about discoveries? Well, in the plate tectonic discovery, they discovered spreading ridges and subduction zones like that. In the case of the Portuguese voyages, they discovered wind gyres, which means wind kind of that goes around in a big circle like that, which is what happens out in the Atlantic. And they discovered that there was vegetation at the equator. They discovered you could get to the Atlantic Ocean. All of these things which are fundamental things about the Earth. So now I want to show you something that this is a part that I love. Okay, so here we are. Here is Iberia. Portugal is this part. Lisbon is there. Here is Sagres, where Henry had his Oceanographic Institute, if you want to call it that. There's Gibraltar, Mediterranean. Now we're coming down. These are the Canary Islands. And right there is a cape called Bojador. And it doesn't look very impressive. You look at it on a map or a satellite or Google Earth, it doesn't look very impressive. And that cape stopped the explorers for decades. And in fact, here if we look at it in more detail, there's the Canary Islands. This is one cape. Here's Bojador. That doesn't look like much, does it? It's not high, rugged, anything like that. But what happened was that Henry would send out a caravel, and the captain would sail as far as Cape Bojador, and then he would turn around and he would go back and he would say, "I'm sorry, Your Highness, we can't get past that." And then Henry would he would go and sack the treasury of the Knights of Christ for get some more money and send out another expedition. Same thing would happen. There were, I forget how many, at least 14 expeditions that turned back right there. How could that be? Why didn't they just keep going? Well, if you read accounts of the voyages of discovery, what they will tell you is that these were superstitious medieval guys, and they were scared. And they thought that if you went beyond Cape Bojador, there would be sea dragons, and they'd eat you up, or maybe you'd fall off the edge of the earth or something like that. And that's why they wouldn't go any farther. I think that's completely wrong, and it's really fun figuring this out with Enrique. These guys were not superstitious. They had navigational instruments. They knew exactly what they were doing, and still they wouldn't go by. Why do you suppose? Weather? Winds. Yeah, weather, and specifically winds. Okay, and here's what was going on. If you look at this satellite image and look inside those circles right there, can you see there's some sort of a feature there and a long stream of sand that goes, we're in the Sahara here, so there's a lot of sand. You can see that the wind has blown that sand right downwind like that. So what that means is that right through here, the winds, these are trade winds, they're just howling through there all the time. They blow like fury from northeast to southwest, and they don't let up. It's always blowing like that. Okay, so here, for example, the problem then is that if you're one of these little caravels, even though you can tack, if you go, the farther you go, the more times you've got to tack in order to get back to Sagres. And anybody who tacks sailboats knows that it gets tedious after a while, you know? If you have to tack 800 times to get back to Sagres, you aren't going to like it very much. And so I think that's why these guys didn't go any farther. And here is a picture showing the wind arrows. Now here is Bojador, here are the Canary Islands. This is just a typical day. And these arrows mean that the wind is blowing like that. In other words, like this. That's the trade winds. And they blow hard and fast and relentlessly. And that's part of understanding atmospheric science, right? Okay, so what happened? Finally, now, in 1434, this guy, Gilles Ayanish, who was he must have been on the 15th expedition, he sailed past Bojador, and he came home to tell what had happened. How do you suppose he did that? And it wasn't by tacking, 1,200 times rather than 800 times, right? Well, it was possible, and I'm going to tell you now, this is what Enrique thinks happened, and he's a historian, and he makes the point, however, that the Portuguese did not publish records of this. These were trade secrets, you know, what they were finding out. And what's more, there was this terrible earthquake in the 18th century in Lisbon, and a lot of stuff was destroyed. So we will probably never have records that tell us. But this is a reasonable inference from a guy whose father was a Portuguese naval captain and knows about ships and things. So anyhow, Julianisch went past it. Now let's see what was going on. Here is a map of the North Atlantic. There's Boston, here's Florida, there's Cuba over here, there's Sagres, there's Cape Bojador. This is a typical day in the North Atlantic with the winds blowing in this big spiral like that. So this is called a gyre, a G-Y-R-E. And this, we think, is probably what Julianisch did. He sailed down to Cape Bojador, and instead of turning around and tacking all of those hundreds of times to get back, what he did was he sailed with the wind behind him around that great big loop like that and continued and came right back to Sagres. He probably didn't have to tack even once. Isn't that neat? Isn't that just about the cleverest thing you ever saw? Now, how would he know to do that? Did he just say, well, I'm going to sail out to sea and find out what happened? Well, what Enrique pointed out to me was that these islands here out in the middle of the Atlantic are called the Azores. They apparently had been known in antiquity, but they were rediscovered by accident in 1427. Probably some Portuguese sailor was out here and got caught in a storm that blew him that way, and he thought he was going to die, and all of a sudden there were some islands. Oh, praise the Lord, we're saved. And then using those as a base, then they would have explored around here and discovered that the winds do this. And look at the time. This is 1427. That's when they would have first started exploring around the Azores. 7 years later, in 1434, Julianisch goes to Bojador and comes home. We don't know that he did it this way, but very likely. So there's a lot of what would you say, speculation in this, but reasonable speculation. So this is the kind of things these guys were doing, and it wasn't just geography. This is geology that they're doing. This is earth science. Okay? So then let's see what happens now as the exploration goes on. Once they got past Bojador, then they knew they could do anything, and so they sailed around here, and that was, they passed Cape Bojador in 1434, and all the way down here by 1498, so we're talking about 60 years later, they get all the way to the Cape of Good Hope. And that's where you find out that you can get into the Indian Ocean. At one point I asked Enrique, well, Bartolomeo Dias, that's this guy, got there in 1488 using caravels. I said, how did he know that he was in the Indian Ocean? You know, maybe the coastline would have just gone around like this and maybe he wasn't there. And Enrique said, well, probably what would have happened was that he would have met some Arab sailors, because they were trading up and down this whole east coast of Africa. And they would have said to him, oh yeah, from here you can sail right to India. And he would say, oh my God, we're in the Indian Ocean. It's not closed, it's open. So now, here's another mystery and a sort of a speculative answer to it. So Bartolomeo Dias gets to the Cape of Good Hope in 1488 using caravels, because those are what the explorers use. And then, and this is the great prize, right? And suddenly they know they can get to the Indian Ocean. Then they don't do anything. 10 years pass. And the next time they go there, it's the famous Vasco da Gama in 1498, and he goes there with naus, with the big ships, and they're packed with stuff to trade, because they're going to go to India, and they're going to trade with whoever's there, and they're going to bring back spices and stuff like that. So what happened in that 10 years? What do you suppose? Funding? I don't think so, because this is the prize. You know, this is what they've been after the whole time. Otherwise it was just science, you know, just exploration. But now they've got an economic motivation. Well, the thing was that you have to get home, or if you're going to use naus. Let me start that again. If you're going to use caravels, you can't carry very much goods, because those are little tiny ships. If you want to trade, you got to use a nau. But if you're going to use a nau, you have to know how the winds blow, because you have to plot a course so that the winds are always behind you. And so what Enrique suspects they did, and he says we'll never know because the documents are gone if there ever were any documents, he suspects that they used that 10 years between 1488 and 1498 to find out what the winds were doing in the South Atlantic. And what they discovered is just like there's a gyre that goes like this in the North Atlantic, so there's a gyre that goes like this in the South Atlantic. So they could plot their courses so that the naus could sail with the wind behind them and all packed full of cargo. And it took them probably 10 years, Enrique suspects, to map the winds here. And he's got one piece of evidence for that that's really cool. And that is that Brazil, this point, this easternmost point in Brazil, was accidentally discovered by a Portuguese who has the interesting last name of Alvarez. At any rate, he discovered it by accident in the year of 1490. So that means that 2 years after this guy got here, there were Portuguese not just sailing down the coast, but way over here. So chances are what they were doing was mapping the winds so that they could use those to plot courses for the naus. Michelle.
So both Diaz and Gama took place, like they have stories about them in the New World and like the Mayans and the Aztecs.
Do they?
I don't remember.
I'm surprised. I would think that would be somebody else. I would think that that would probably be the Spanish finding that out. Yeah, I think these guys were going to the Indian Ocean. So you may be right, but I'd be a little skeptical. Okay. All right. So then, now we've seen something about the discoveries. This is how they discovered the wind gyres, and now there was an excitement. And I just tell you about the excitement. So in the plate tectonic revolution, you just can't believe how exhilarating the meetings were. You know, some of you have probably been to scientific meetings. Surely David and Ryan have. And, you know, you go to a lecture and you read about it, take notes, and you talk with your friends, and you go to another and you go out and have lunch. You know, you see, well, what shall I look at this afternoon? It was different in a scientific revolution. I got to go to a meeting in 1967, which was one of the 3 or 4 meetings where the plate tectonic revolution crystallized. And at the time, I was a grad student at Princeton. I had a professor named Walter Elsasser, who was German. And he was, first of all, very, very difficult to understand. And what's more, his expression or his tone of voice never changed from something about like this. And we never saw him express the slightest emotion about anything when we were students. At that meeting, when plate tectonics was just breaking through and people were discovering for the first time about plate tectonics that this was a breakthrough understanding, at one point I was hurrying down the hall to go to a session, and here comes Professor Elsasser, who I didn't think he even knew my name. He throws his arms around me and he says, "We are witnessing erosion," and then he takes off to go to I mean, it was like nothing you've ever seen. As scientists don't usually behave like this, and that's really what happened. And I think that was what was going on with that Manueline architecture. This is what was going on. These people were excited by what was coming in the port. And Enrique tells me about a case where it's documented that ships would come back, explorer ships would come back, and they would come into the gate of Lisbon Harbor, and people would go running down to the docks to see what kind of novelties they'd brought back. This was an utter change, because you picture the Middle Ages. Nothing changed very rapidly at all. You know, if you were most people in the Middle Ages up to this time, they were probably born, lived near where they were born, died there, and never saw anything different as an adult from exactly what they saw as a child and what their grandfather saw as a child, right? This was the assault of novelty upon Europeans, and here is a good symbol of that. This is Albrecht Dürer's drawing of a rhinoceros. Now, this rhinoceros was brought back to Lisbon from India by India. I would have thought, I don't know, That's what it said. I would have thought that was from Africa. But at any rate, apparently Dürer, who was the great German artist, never saw the rhinoceros, but apparently the word that came out was that, well, it's kind of like this big animal, and it's like he's wearing a suit of armor, you know? And so you can see that the rhinoceros is wearing a suit of armor there. But this was the, as I say, this implacable assault of novelty on what had been this very conservative European word. So here's Alsasser, we're witnessing a revolution. And here's an example, recognition of change. So there's Alsasser. And the Portuguese knew they were changing things with this thing. For example, here is a quote from one of the Portuguese scholars. He says, with becoming modesty, he says, "I say that more is now known in one day by the Portuguese than could be known in 100 years by the Romans." So these guys knew they were changing things, that this was this revolutionary thing. Okay, you know what happens when I get excited about this stuff? I run long. This is going to be continued on Tuesday, and thank you for your attention.